Hello, welcome to another video of Engineering Economics, INEN 2373. In this video we're going to talk about fixed and variable cost and its relation to the break-even point. The easiest way to explain this is by means of a graph. So let's you can find more about this topic on section 16.2.4 starting on page 775. I'm going to try to reproduce here what you have, a similar graph of what you have in figure 16.2 on page 777. It is not going to be exactly the same, but it's similar. And let's say that here we have a graph in which here we have dollars and we have quantity. And we're going to make a graph that represents, this is a horizontal line that represents fixed cost. And also you will have variable costs, that is, the more you produce, the more you will consume, the more you have to pay. These are variable costs. So when we add these two together, variable cost plus fixed cost, you have all the costs that a company incurs. This of course is supposed to be a straight line, and this is total cost. And the key question is, how does this relate to the revenue? And for that, the revenue is the price times the number of units we sell, and we would have another line, and hopefully that price will be larger than the cost per unit, in such a way that eventually the revenues would exceed the total cost. So this is revenue, and here there is a point in which these two lines meet each other, and that line is where that point is where we are going to have our break-even point. That it's here we have the point when these two lines meet, when these two, the cost of producing all these products and the revenue associated with selling those products is the same for this particular quantity, and that would be the break-even point. Fortunately, computing that break-even point is very simple. All we need to do is make the following computations. The break-even point for this situation, we're going to denote that with Q star, is all the fixed cost divided by the difference of the price minus the cost per unit, or the unit cost. And here we have the fixed cost. So let's make an example. Let's say that the fixed costs in a particular manufacturing plant is $1 million, and that's a fixed cost, say, per month. That is, every month, regardless of the number of units produced, there are costs associated that will be the same, say for instance insurance and some elements of the manpower that they have, and other factors not associated directly with the number of units to be produced. And let's say that the cost per unit for each one of these products, that is the unit cost, is say $20, and the price at which they could sell is say $60. Now the break-even point, that it's how many units that we need to sell to start making a profit, would be 1 million divided by 60 minus 20. Naturally, this quantity is easily computed, and we need to sell 25,000 units just to break even. Very good. Now let's say that the capacity of the plant is 80,000 units. What's the maximum profits that a company can make? Under this maximum capacity? Well, if we can produce 80,000, that means the first 25,000 are only dedicated just to cover the fixed cost. That means that the difference between 80,000 and 25,000, which is 55,000, that is 80,000 minus 25,000. That's the number of units we're going to be able to dedicate to make actual profits. And the profits that we're going to be doing is the difference per unit is 60 minus 20. So that's the maximum profits that we can get when we produce this. And let's see, 80,000 minus 25,000 is 55,000. That times 40. The maximum profits that the company could do at working at full capacity would be $2,200,000 per month. You can check these answers in your book and read that section, 16.2.4, and if you have questions, let me know.